Bon001 stroke ZKO is a sample from an ancient ceramic Neolithic Anatolian farmer unearthed at the Boncuklu archaeological site, which is a mound formed by the oldest inhabited village of the Anatolian plateau. It's located on the Konya plain near the city of Pınarbaşı in central Turkey. The site is radiocarbon dated to be from 8,300 to 7,600 Cal BC. DNA extraction was performed from his petrous bone. His skeletal remains were estimated to be from 8,300 to 5,800 Cal BCE. His mitochondrial DNA haplogroup was predicted to be U3, while his Y chromosomal DNA haplogroup was G2A, 2B, 2B. This individual had a full skeleton buried by inhumation under the plaster floor of a mud brick building. Iranian Zagros and Anatolian centers happened independently or without gene flow, evolving from the local hunter-gatherers. The genetic affinity of the aceramic Neolithic Anatolian farmers to the local Mesolithic hunter-gatherers is around 80 to 90%. However, later they received a small genetic influx from the Iberian, Caucasian and Levantine population. This population inhabited Boncuklu seems to be transitioning from a hunter-gatherer subsistence to a settled farming subsistence. They relied on hunting wild boar, wild cattle and wetland birds, completing with gathering nuts and wild fruits. The diet was completed with a small amount of cultivated wheat, lentils and peas. Their microlithic tool technology shows similarity to the early hunter-gatherer technologies of the Pınarbaşı site than to the technology of Levantine pre-pottery Neolithic sites. The principal component analysis, PCA, shows strong evidence of continuity and similarity of the Boncuklu population to the earlier Epi-Paleolithic Pınarbaşı hunter-gatherers or even earlier Holocene foragers. It's hypothesized that around 8,300 Cal BC, the local foragers began the cultivation of domesticated plants. The Pınarbaşı population, although started adapting a more sedentary life, their diet lacked any sign of cultivated plants. The Boncuklu pre-pottery Neolithic population constructed oval-shaped mud brick buildings that were rebuilt over generations, although most of the time they buried the dead under the house floor. Intentionally disarticulated skeletal remains, especially skulls, were found in the space among the buildings. According to the analysis of the relevant nucleoid positions, Bon001 did not possess the derivative allele for lactose persistence. He had decreased risk of malaria, and although he had darker skin and hair, he possessed both derivative alleles for the light eye colour, HERC-C2 RS129 13832. His mitochondrial DNA haplogroup, the U3, is hypothesized to originate in the Near East in the Upper Paleolithic. Its highest frequency even today is in the Near East and the Caucasus. His Y chromosome haplogroup, the G2A2B2B, is rare, and it was found in an ancient Hungarian sample beside the Bon001. ZKO seems to be rare, and modern day people having this haplogroup usually originate from Turkey, Armenia and the Lebanon. So there was other samples found at the site, and geneticists have successfully sequenced ancient DNA from at least 22 individuals excavated at the site, dated between roughly 8,600 BC and 5,353 BC. A few notable examples of the individuals found alongside Bon001 include Bon004, another highly studied adult male from the site. Like Bon001, he belonged to the paternal Y DNA haplogroup G2A and maternal haplogroup U3. Bon002, an adult female found in a similar subfloor domestic context, Her maternal lineage was sequenced as mtDNA haplogroup K1A, which is another major genetic marker that early Anatolian farmers spread into Europe. Bon005, an individual whose maternal lineage belongs to mtDNA haplogroup N1A, a signature marker heavily associated with the expanding Europe Neolithic farm wave. Several neonates and young children have been excavated under the household floors. Interestingly, comparative DNA testing across early Anatolian sites shows that while some houses contained close relatives, others included children who were completely unrelated to the adults in the same structure. Other fascinating finds: the human dog burials. In addition to other humans, extraordinary new archaeological findings published in Nature reveal that the people of Boncuklu buried domestic dogs directly alongside or within human graves. These are among the oldest genetically confirmed domestic dogs in the region, 10,500 years old. They were buried with intent and care, signaling that these animals held a deep symbolic and practical companion role, likely helping the community guard their new villages, hunt, or manage early sheep herds. So, my mtDNA J1C3 fits into this exact same evolutionary and historical narrative. While the specific branch J1C3 itself is slightly younger and has not been sequenced directly in the earliest aceramic or pre-pottery layers of Boncuklu Hoyuk, its parent lineage, haplogroup J, was a major player in the exact same Near Eastern demographic expansion. Just like U3, K1A, N1A and X2, J1C3 traces its roots back to macro haplogroup N. If you travel backwards in time, here is where J1C3 emerges with the others. Convergence with U3 and K1A. Around 55,000 years ago, a massive maternal branch called haplogroup R emerged. While R gave rise to U3 and K1A, it also split to form haplogroup JT. The birth of haplogroup J, roughly 33,000 to 45,000 years ago in the Near East, Western Asia. The JT branch split into haplogroup T and haplogroup J. The evolution of J1C3, the lineage continued to mutate through the Ice Age. J1, 25,000 years ago. J1C, 12,000 years ago. J1C3, 9,000 to 7,000, 9,000 years ago, or 7,000 BCE. Because J1C3 formed right around the climax of the Neolithic agricultural revolution, it's a classic Neolithic farmer marker. The sequenced individuals at Boncuklu Hoyuk date to around 8,300 to 7,600 BCE. At this early stage, the JC1 parent lineage existed in the region, but the specific J1C3 sub-branch had likely not fully mutated or expanded yet. The later European migration, as the descendant populations of these Anatolian farmers migrated westward, J1C3 became heavily integrated into the expanding agricultural wave. It's frequently found in subsequent Neolithic cultures in Europe, such as the linear pottery culture in France and Germany, alongside K1A and N1A. So, in summary, the big picture: if you imagine a family reunion of the Boncuklu maternal lines, J1C3 is a close cousin. It shared an extended Paleolithic history with U3 and K1A by the haplogroup R lineage, developed in the same Near Eastern zone during the Ice Age, and ultimately travelled the exact same geographic paths into Europe as part of the early farming diaspora. Next up to look at in the Mesolithic, oldest South American inhabitant, Los Vilos commune, Coquimbo region, Chile. I matched 0.05%, and apparently I'm genetically closer to this sample than 42.44% of other genome link users.